Good evening, everybody. I am Jayshree from SNS College of Technology from the Department of Biomedical Engineering. So I am going to take rectifiers and power supplies. The title is what? Under this, I am going to take full wave rectifier part 2. So before going to see the full wave rectifier part 2, so let us be revise that what do you mean by half wave rectifier and what do you mean by full wave rectifier, and then let us go this topic. Okay. Initially we have seen that half wave rectifier contains only one diode, whereas the output comes only one half cycle of this input. Whereas in full wave rectifier, the circuit contains two diodes, the output contains continuous positive half cycle irrespective of negative cycle. And these are the examples of half wave and full wave rectifiers. Let us see the classification of full wave rectifiers in this part 2. So center tapped full wave rectifier and full wave bridge rectifier, these are the components we have to see this full wave rectifier. So this is what this center tapped windings. Here the primary windings are more when compared to the secondary windings, and here the AC input is given as the input, and here the output is continuous AC waveform with positive half cycle only. So this is what the full wave bridge wave rectifier D1 and D2, D3, D4. So it forms like a bridge D1, D2, D3, D4, and when D1 and D3 connects, D2 and D4 is cut off. When D2 and D3 connects, D1, D4 is off. Let us see this. And the bridge rectifier, in one end is connected to this, top end is connected to the AC supply, and bottom end is connected to the ground. So this is what the construction of center tapped full wave rectifier. The center tapped full wave rectifier consisting of two diodes, resistive load. So the center tap transformer, it is normal transformer with one slight modulation. It has an additional wire connected to the exact center of the secondary winding. This types of construction divides the AC voltage into two equal and opposite voltages, namely positive voltage and negative voltage. Next one is what? Primary winding and secondary winding. So in this center tap transformer, in the secondary winding only the center tap is connected. Here V is equal to VA plus VB, where VA is nothing but the top end of the voltage and VB is nothing but the bottom end of the secondary winding voltage. So this all together forms this AC input, which gives the output is this V is equal to VA plus VB. That is what this DC ideate DT, design thinking ideate stage. Next one is what? Center tap transformer, this primary winding and secondary winding. This CT and this D1 and D2 form this primary and secondary windings. So which gives the AC input and which gives only positive half cycle of this DC input. That is only peak value will come. Next one is what? Working of the center tap full wave rectifier. We apply AC voltage to the input of the transformer. During positive half cycle of the AC voltage, the terminal 1 will be positive and the center tap will be 0 at 0 potential, and the terminal 2 will be the negative potential. So suppose let us take the AC input contains one full waveform, positive and negative cycle, and this forms this during positive half cycle. This D1 forms this output which gives the forward bias, whereas in negative cycle this D2 forms this another half cycle. That is what the full wave rectifier contains continuous half cycle present at this output side. So this will lead to forward bias in diode D1 and causes current to flow through it. So during this time D2 is in reverse bias and will block the current through it. And this is what the circuit which contains the D1 only conducts as its forward bias, and D2 is reverse bias that does not conduct any cycle. This is what this second half cycle, this is only D2 only conduct, whereas D1 is reverse bias and D2 is forward bias. During negative half cycle of the AC input, the terminal 2 will become positive and related to the terminal 2. So that's all about this construction of full wave rectifier with the two diodes and positive cycle and negative cycle, which gives the output only when the diode is forward bias, irrespective of other diode. When D1 is forward bias, the output will come. When D2 is forward bias, the output will come. Whatever may be the cases, one diode will conduct and other diode will be in reverse bias. So thank you all. Have a great day.